Okay, this is for the third page of the review, page 10H, from the practice packet. Should look like this. All right, so actually to start though, I want to let you know that so we're looking to sketch the graph of the function onto here and then convert to vertex form using completing the square. The truth is it's going to be a lot easier if you start with the calculator. So I'm going to pull up the calculator now. So using the y equals button right here, we will just punch in our equation. Let's see, I turn it on. Y equals. Clear that out. So we have negative x squared minus 8x minus 18. And then let's see what that looks like. So you got this graph that's going to look like that. Now we don't know the exact points and where to put them over here on this. So we're going to have to pull up some points using the table. And that'll give us some usable points. So I actually did that already, but I'm going to go back and show you how I did that. I just hit second table, and I get this x, y ordered pairs from my graph. So now this gives me some points that I can chart, and if you look closely, you'll find the vertex where you have a couple of y values that are identical. So I have a y of -3, y -2, y -3. When we have those ones that are identical above and below a number, that one in the middle, that's our vertex. So our vertex in this case is -4, -2. So I'm going to go on. I'm going to make a list of points here. So I have -1, -2. I have. I can use -5, -3, and -6, -6. Those will all fit onto my graph here, as well as -4, -2. Sorry, -3, -3, and -2, -6. So those are some points I could use. I'm going to put some of those on here. You only really needed to use a few, but let's go ahead and do that. So if I go back to my chart, get my pen going again. I had a vertex at -4, -2. Put a point there. I had a point at -5, -3. And I had a point at -6, -6. I also had a point at -3, -3. And at -2, -6. So we can see this graph looks like this. The graph of this quadratic. We knew it was going down because it had the minus sign out in front. But now we have some viable points. So now that we look at that, our vertex is -4, -2. And since the vertex form is y equals a parenthesis x minus h squared plus k, where the vertex is, this is my x value. Should have done that in red. And this is my y value. Well, in the case of the equation we had, or should say the graph that we have, we know that our x value is -4 and our y value of the coordinate is -2. So we can back into that equation and just write it this way. I should put this in blue now, down here. Y equals, we know it's -1 because you have that negative out in front. Parenthesis, x plus 4 squared minus 2. Because we get the opposite, so because our actual vertex was at -4, -2, the x, we use the inverse of this, and then, not the inverse, but we change the sign. So if we see this equation, we would know right away that this vertex was at -4, -2. Because we change this sign, we keep this one. And this is the x part of it, and this is the y. All right, that's enough for that one. I'm going to go ahead and show you number 16, because that one we can do a little easier using completing the square. So let's give that one a try. I have this equation, y equals x squared minus 6x plus 5. Let's write that over here. I'm going to encroach a little bit on this one. And in order to complete the square, I need to make a little bit of space in here. So I'm going to write it again, but this time I'm going to add that value, that mystery number that's going to make a perfect square that I can write more simply. So I'm going to add something, and then I'm going to take it away, and I'm going to add it to 5 again out here. So that 5 just kind of moved off to the side. We'll use it still. But the mystery number I'm looking for, and I'll do that in green, is half of this b value, this -6, is -3, and then we square that. So that's b over 2 squared. In this case, that's -6 divided by 2 is -3 squared, or 9. And then I'm going to subtract that over here. So we're finding it's a lot of numbers, but what ends up happening is I can condense this, simplify it by just saying that is x minus 3 squared. We still have our y equals over here. X minus 3 squared. And then -9 plus 5 is -4. And now we've essentially found our vertex for this graph of this quadratic, because I take the reverse of this. So I'm going to say my vertex is at +3, -4. Let's go ahead and find that over here. Let's go over to 3, down to 4, and that's where we're going to start this thing. And then from that point on, I've got the vertex form that I was supposed to. That's this right here. And I can just use my calculator to find those other points. So you'll find that there's one right here. Another one right here, and then the intercepts are going to be at 1 and 5. That's where y is equal to 0. So if I draw that graph, it should look like this. I'll do my best. I missed on the right a little bit. Hard to do on the computer here. All right, that's how you do those two. All right, the hard work's over on this page. Now this one, number 17, we're just going to sketch the graph of each function, identifying the vertex, the y-intercept, the x-intercept, and the axis of symmetry. Not as hard as it seems. As we said before, they're showing us the vertex. We're going to change this. This is going to be the x portion of the coordinate. So we're going to have a vertex, and the x, we're going to change that sign, so that's going to be 4, and the y, we're going to leave it alone. So we have a vertex at 4, 4. Let's draw that one in. Now, how do we find the x-intercepts? I should say, how do we find the y-intercept? That's when x is equal to 0. So I'm going to write that in. 0 equals negative x minus 4 squared plus 4. Subtract that 4 from both sides. Come on, I said red. So now we have negative 4 equals negative x minus 4 squared. We got to get rid of that negative, so I'm going to divide both sides by negative 1. We'll have 4 equals x minus 4 squared. This is where I can take roots. So I'm going to flip these so the x is on the left. And we have x minus 4 equals plus or minus, and the square root of 4 is just 2. And then we'll bring that 4, I'm going to write over here, x minus 4 equals plus or minus 2. Let's add 4 to both sides. X equals, whoa, just realized I wrote 2. Said 4, wrote 2. Equals 4 plus or minus 2. So my two answers are x equals 4 plus 2 and x equals 4 minus 2. 4 plus 2 is 6. 4 minus 2 is 2. So I found my intercepts. So my intercepts are going to be here at 2. And at 6. I've got enough to graph this thing now. I know through experience that I'm going to have a point here and here. We don't have to talk about that right now. And then we can graph that. I do have to identify the y-intercept, which is actually pretty easy because that's when we set x equal to 0. We'll get to that in a sec. Let me graph this thing. All right. Now let's find that y-intercept. I'm going to write right on this graph here. We'll do that in green. So the y-intercept is when x is equal to 0. So I'm going to say y equals negative parentheses 0 minus 4 squared plus 4. I'm just doing a little bit of math. Y equals negative 4 squared is 16. Plus 4, and being the mathematicians that we are, y equals negative 12. So our y-intercept is when the x is 0, and we know it's at negative 12. That's ours. All of this work is for this problem number 17. Hopefully you have room on your paper to write down below it. I just didn't have the room because of the way this program constrains me. That's it for this page. 10H is finished. Hit pause. Actually, you don't have to hit pause. And you can move on to the next video if you need help on page 11.